Good morning everybody, and welcome to Continuous Delivery in Java. Things that we learn by hurting ourselves. My name is Paolo, and I work as a developer in Xpeppers. Xpeppers is a company which provides software development, training and coaching on Agile methodologies, and we help companies to, let's say, shape and move the infrastructure towards the cloud. You can find me on Twitter. I'm Beating Out. I'm sad to say that I'm very boring. I talk especially about functional programming, so Erlang Elixir, software development, and of course continuous delivery. So, just a little question. What is continuous delivery? How many of you know the meaning of continuous delivery? Good. Some are cheating there. And how many of you actually practice continuous delivery daily in your projects? Good. So, for those of you that know what continuous delivery is, I'm pretty sure that you passed through this sentence, which is extracted from Martin Fowler's blog. And Martin Fowler is sort of, let's say, one of the father of the good software development. And he has a blog post about everything. And in one of those blog posts, he is speaking about continuous delivery, and he says that continuous delivery is that software development discipline where you build software in such a way that you can deploy that software at any time with confidence, at any time. The important part is that you can deploy your code at any time. Well, I'm not Martin Fowler, of course. But I can say that after a couple of years, my team and I we decided to adopt another definition, this one. So for us, continuous delivery is nothing more than reducing the stress that we undergo when we deploy, when we deliver business value to our customers. Because, I don't know for you, but for me, in the past, delivering software was painful, was stressful. You can come and ask for different experiences. We are here, you can ask, me and my colleagues can talk to you. Okay, we have seen briefly what continuous delivery is, but what continuous delivery is not. Continuous delivery is not continuous integration. How many of you here know services like Travis or CodeSheet and build their code base there? Let's say they run tests. How many of you run tests on your code? Okay, good. But just because you run tests on your code, you are not doing continuous delivery. Because you are not delivering in a safe way, in an automatic way, business value to your customer. Continuous delivery is not continuous deployment. Let's say that for an Italian, at least, the terms are similar, but the meaning is very different. When you do continuous deployment, you are continuously putting software in production. Every time your code passes through your tests, your build process, that code goes straight to production. In continuous delivery, it is not like that. Because let's say that the last step, the last part of the process, the deployment process, is not automated. Well, it is automated, but you have to have sort of, let's say, someone, probably your product owner, is the one that decides that a given feature goes to production. So the meaning is different. You can see, in one case you deploy everything, in the other case you decide to deploy something. Finally, continuous delivery is a mindset which is different from giving rules, as we in Xpeppers gave these rules in the past. Some rules like we don't deploy on Friday, or we don't deploy code after 5 p.m. Because if something goes wrong, we have to stay here till 8 p.m. So please, stop giving yourself rules like this one. Technically speaking, what is continuous delivery? So, How many of you here are software developers or technical people? Okay, good. So, technically speaking, continuous delivery is a lot of things. Writing software. I'm a software developer. I write software. It's not only writing software. You have to test your software. And it seems strange to, in an Agile conference, to speak about tests. But believe me, I've seen many companies, not much, but many companies which are not testing their software before putting the code in production, with the risk of losing money if something goes wrong. It's not only writing software and testing software. Every code base I've seen had a database. You have data. So you have to build your database and probably migrate your database, because data and data schemes never remain the same over the years. I think that you followed the keynote, and there was speaking about DevOps and everything. Okay, for me, continuous delivery is not only writing software, testing software, and preparing your databases, but you have to be ready to prepare your machines in an automatic way, in an automatic fashion, so that you can repeat all your machine in the same way. But most important, with continuous delivery, you have to give an automatic way to deploy at any time with confidence the software to your customer in production. I've seen 3 ways of deploying software over the years. First way, most classic way, product style. So there are 2 different ways of doing this. The first one, developers write the code, give the artifact to IT people, probably they hate each other, and then IT people put the software in production, something goes wrong. Okay, open a ticket to that team. We are okay, open a ticket to IT guys. It doesn't work like that. If you are lucky, you pick one person from the dev team, one person from the IT part of your company, and they work together to deploy the software, by hand, obviously. And probably they wear a cowboy hat, because nobody should bother them, because it is very risky to deploy software. And they call home saying, okay, you know what, I'm not coming home, because I don't know, something can go wrong. So, this is not continuous delivery, this is wrong. How can you say you are there? Probably you don't have tests. Test your software, please. You deploy your artifact in a manual way. If something goes wrong, what happens? I don't know. Your environments are snowflakes. They are each other different. They are created by hand, probably by someone that it is no more in your company. I know stories where people cannot touch their machines because they don't know how the machine was created. The outcome is not predictable. You don't know what happens when you put code in production. And finally, there is no collaboration. We are talking about Agile here. Agile is important. Collaboration is the key value. All the team, not only the dev team, not only the IT team, there is one team. Everybody should work together. If you keep on doing Rodeo style, this is the effect you get. Second way, the perfect way, buy the book. This book is, of course, Continuous Delivery by Jess Humble and David Farley, and they are sort of the gurus of the argument. And, well, I can say that this book is perfect, and it describes how you can build a perfect deployment pipeline. And I can say that, okay, this is the good way of deploying software, but I know that it is impossible to read this book and believe that after a couple of weeks you can have the same pipeline, you can have the same procedures. It is impossible. But there are signals that can show that you are actually doing your process in a good way, you are sort of achieving these results. First of all, you have fast feedback. And it seems surprising, it can be surprising, but I'm talking about bad feedback. Why? Because when I build a pipeline, I build it in a way so that I'm sure that errors are caught as soon as possible. I write tests so that if something is wrong, the pipeline breaks as soon as possible. If I have tests that break more often than the others, I put those tests at the beginning of my pipeline. Because only if my pipeline breaks early, I can fix it early. Secondly, done is released. I'm a software developer. I know that we have this way of doing things so that we say, okay, our code is ready. Our job is finished. No, it doesn't work like that. Because as a software developer, is my responsibility, is our responsibility to be sure that that software is put in production. Our job is finished only at that point. Responsibility is shared, and everything is automated. More than that, your process is reliable and repeatable. Automation here is the key. I work in X-Peppers. We do apply Agile methodologies. And we believe in iterating. So actually what we do, and what I suggest you to do if you are new to the topic, is just start small and iterate. So that you can change the way you are doing things and adapt according to your needs and to your problems. And here starts my story. And actually it's a story of a project I've worked in, but it could be the story of any project that X-Peppers works in. So in this project there were two souls. The part of the team was made up by two souls. One part of the team was familiar with continuous integration and wanted to achieve a better result, to give better business value to our customer by employing continuous delivery practices. And the second part of the team was a team that didn't know actually some technical practices, but that was really eager to learn more and to learn, adapt, change. And actually, this project was about the redoing of a previous application in Java. It was a greenfield project. And okay, we discussed about all the domain, everything, what the software should do, but we discussed also on how this software should have been deployed to production. So we sat down and we analyzed some of the key things that we knew about the way of deploying software previously. So, what did we know? Well, we know that the previous way of deploying the software was painful. It was a stressful operation. It was done by hand. There was no automation, sorry. And actually, we knew also that the database, okay, I have to say that I'm one of those guys, social ethics, that say the database is just a projection of your domain. So we first build in an iterative way our domain, and then the database follows the domain. So we knew the database would have changed in a continuous way. We knew also that we had to deal with different environments that actually, and unfortunately, were not ready in a short time. So, we decided to employ the first part of the project time exploring the domain of the project, so that the part of the team that didn't know the previous domain could learn the domain, and the part of the team that knew the domain but not the practical, let's say, the practices, the technical practices, had the time to learn the practices. So, actually, the first iteration on our continuous deployment pipeline was an iteration without automation. How we did things? Well, actually, to speed up our deployment process, we decided to create an environment replica on AWS. So we create all the application server and the database on AWS, and for that time AWS was our production. The build was still manual, so each member of the team could build with Maven the artifact, and then it could deploy with SCP to the JPOS the artifact. The database was migrated as it was migrated in the previous project by hand. So you connect to DB and you migrate to DB. It was our choice. No automation was a choice. So that we could give the people the time to learn what they had to learn. We felt like this. Do you remember the big rock which is following you when you know that something is going wrong? Oh my God. Why? Well, no automation at all, obviously. So no continuous delivery in practice. And the problem was that each member of the team could actually deploy, but we didn't know who deployed what, which is not so good, right? So at one point we decided, okay, stop it. We need to do a second iteration over the pipeline, and just not so many things. I mean, just the basic things. And we decided to give a taste of automation to our pipeline. So what will we do? Basically, we set up a basic Jenkins installation. Jenkins is, how many of you here know Jenkins? Oh, great. So, I'm not saying what Jenkins is. Jenkins is just a software and you can make it execute tasks. So we create this Jenkins environment, and basically we set up in Jenkins 2 tasks. On each commit, on each push by a member of the dev team, Jenkins fetched the source code and it ran a set of unit tests and it built the artifact. The artifact was there. And then there was a task which actually, using a tool called Liquibase, migrated DDBs. How many of you know Liquibase? Oh, great. Liquibase is a tool, for those of you that don't know, that lets you express your migration in a better way. You can use XML, because we are in the Java world, or you can use YAML, or you can use, I guess, SQL, yeah, plain SQL. And basically you can attach Liquibase tasks to your Maven, and you can do something like Maven migrate environment, and it applies all the migrations. And then, in the last, there was a task to deploy AWS. The script was the same as we used manually, but this time it was inside the Jenkins. So you just push the button and let it deploy. And I have to say, this kind of human automated interaction worked for a while. It was really good because it was what we need. Because we had the chance to automate something, but we had more time to focus again on the domain, on the practices, on everything. But there is always a but. We discovered something. Actually, something was missing. Why? Our QA, most of the times, not most of the times, but many times came to us saying, okay, you know what? I see MySQL or whatever errors in my web page. Why? Well, actually we had a battery of unit tests, but we did not have integration tests. We did not have some kind of test that proved that all the workflow was correct. Why? We were using, for example, a tool called MyBatis. How many of you here MyBatis? Okay. MyBatis is a Java framework that lets you to connect to your DB and to express your query in an XML way, which is much better than doing the query by yourself. But there is a subtle problem that if you do something wrong in the naming of the fields, basically your query doesn't work anymore. So if you don't have some kind of test which uses the correct MyBatis, you are not getting those kind of errors. More, I say we were using unit tests, we were using mocks, so we were faking our dependencies, but it happened that sometime we forgot to put the correct dependency inside our code. So the unit tests were using a fake database and everything was cool. But in production, oh, there is no database. Nobody put inside the correct database. Wow. But hey, good news. Environments are ready. So now we are ready to deploy our code base to every environment. Iteration number 3. We decided it was time to automate the process of deploying much more than before. So now we want to deploy our application in a single way to all the environments. What did we do? Well, to correct the problem with the integration tests that we did not have, we decided to introduce integration tests. So we put a new Jenkins task, and we put all the tests over the database, all the tests that actually did a HTTP request to the server and check that the data were retrieved from the database. And we discovered something interesting because we decided to track how long were our integration tests. And okay, let's see how long are our unit tests. And we discovered that we had a unit test of 5 seconds, which means that something is wrong because unit tests should be fast. And we discovered that those unit tests were not unit tests because they were reading from the file system, they were doing something strange. And it was mostly due because, let's say, we were still learning how to do correctly unit testing. So that was good. And actually, we were able to deploy to all the environments in the same way, with a click on Jenkins. We just put all the 3 environments, script were the same, just decide the correct variables. So I want to deploy on staging, click, deploy on staging, perfect. Oops, we discovered something interesting. There was a bug. Why? One of my colleagues always repeat that there are 2 big problems in computers or in the IT, timestamps and currency. Well, actually, the point is that in those new machines, we were using a different driver towards the DB, a driver different from the one that we used on AWS. So there was a bug, and our QA was not happy. Okay, no problem. Just roll back the driver on AWS, run all integration tests. Integration tests broken everywhere, blood, everything. No problem. Let's fix the test. We have tests. Is it okay? Good. Does it work on AWS? Yes. Does it work on the other machines? Yes. QA is happy. But there was a little bit of duplication. To deploy this artifact to the environments, we had 3 different pipelines that had to build the software, the Java code, and then put this Java code built to the machines. And this is wrong. If you read the book that I recommended at the beginning, they say that you should put in production the same software that you built when you run the tests. So something was wrong, because we were building our code base, n times for n environments. Why? Well, sadly, we were using Maven profiles in an incorrect way. So the problem was that we were storing environment configuration inside the Maven profiles. So we had different Maven profiles, and we had to run the build part specifying the Maven profile. And this means that for CI, for continuous delivery, we had one profile, and for each environment we had a different profile. And this was terribly wrong, because we had to build n time our software, and actually it was sort of slowing us down. And we wanted to be super, super, super fast. Here comes the point in which we decided no more Maven profiles, no more duplication. We should have a single artifact deployed to each environment. The same artifact that we are testing heavily previously in the pipeline. So what did we do? Well, we got rid of the map member files, and we use something more sensitive. I mean, JBoss provides already a way for you to store your configuration. So just build your software, your Java code once, and then let JBoss serve for you those variables you need. In this way, we were able to produce a unique artifact and to deploy that artifact to each environment. Cool thing, we decided that we wanted to know which feature we deployed in which environment. So we did a change in our pipeline, and when we fetched the code base from Git, we opened a branch, and we renamed that branch, that Git branch, with the number of the pipeline. Because if you run things in Jenkins, you get a new number. So for example, when something new arrived, we opened the branch 1001, and we use that branch to track our code. We change inside the Maven the POM XML so that we could rename our artifact according to the Jenkins task. And then, when the software was built and passed all the tests, we put that artifact to the Nexus. How many of you know Nexus? Okay, for those of you that don't know Nexus, Nexus is a sort of repository for your Java artifacts. So when you build something, you can put that something somewhere, which is safe, with a number. So you can have multiple versions of your software. And those versions, as I said, came from the number generated by Jenkins. And we started getting really fast. I mean, the pipeline was fast, and we were fast doing things. We were writing tests, doing tests, super speedy way, everything. Oops, something was not good. Well, our QA was not so happy. Why? When we did not have all the environments we needed, our QA did the manual tests on the iOS machine. And we did not tell to our QA, okay, you can run your tests now on the other machines, on the machines which are ready for you. So it happened that our pipeline was so fast that it deleted some data on the iOS machine, or it put new data on the iOS machine, which screwed the manual test our QA was doing. And believe me, it is not really nice to have the daily stand up with something which is pissed with you. Other problem, we had a lot of branches. As I said before, your code base, your software is not owned only by the development team. Other people are working with the software. So in our case, other people were pulling the project, were downloaded the code base from something remote, from Git in our case. And actually, using branches means that whoever is pulling down the software is getting all the branches. So we had people who were not really familiar with Git, that every, let's say, half an hour, 15 minutes, 50 minutes, had new branches. And they did not understand what was happening. Not good. And finally, we decided that we needed a last iteration of the pipeline. We decided that the pipeline had to be a common value between all the people involved in the project. So I call this iteration make them happy, because that's what we try to do. We try to make people happy. So what did we do? Okay, we solved the problem with the QA. We said, okay, you know what? You should run your test in the other environment. And sorry if we forgot to tell you. Then we decided that branches were not good anymore. Why? Because Git gives a better instrument, tags. Tags means that whenever you download your version of the source, you can tag that version and give, okay, let's say this commit is version 1.1.5. In our case, the git tag was the Jenkins build number, so that we sort of preserve the way of doing things. And finally, we decided to track the deployed version. In a simple way, we added a task in Jenkins at each deploy, which brought and still writes a version number in a file. So when we wonder, okay, but for example, in staging, which version do we have? We just need to take a look at the file and we know. This is our whiteboard. And are you familiar with a whiteboard like this? Basically, let me see. Okay, here is the things that we have to do. Here are the things that we plan to do this week, or that we don't have because we are very good. And here are things in progress. A good thing is that we are so confident with our pipeline that whenever a story is ready, we put it here so that we can deploy it to the QA environment manually or during the night in an automatic fashion. All these stories are automatically deployed in QA. More than that, our QA every day tries the stories here, and you can see there is a little sticker, green or red. I don't see colors actually, but they are green or red. And according to the color, we know that something is done the right way or in the wrong way. And if it is in the wrong way, we open another bug here, and we work the bug. Good. We decided on other things. We decided that we needed to express a common domain language, a common jargon, with our product owner, with the people that were, let's say, giving the business way of doing things. So we used a tool called Cucumber. Anyone here using Cucumber? Okay, you are cheating because you are part of the team. So Cucumber is a software tool which helps you to write your user stories in a human language. Then that human language is translated into code, and this code is used to run tests on your code base. So we sat down and we started writing tests that actually could be written by QA or even by the product owner. And this is wonderful, because you have tests that express your domain language in a way that everybody is able to read. No more Java code. Most important, we sat down one day, and after a retrospective, after some talking with all the team, and we asked our product owner, just wondering, do you know that we have something more than 1,000 unit tests on our code base? Good. And do you know that we have 300 integration tests more on our code base? No. Do you know that you can at any time decide in which environment you can deploy what? Wow. No, I don't know it. So the most important thing is that we expressed to our product owners, to the business people, the values behind continuous delivery. And I remember our product owner was really happy because of this. Something that he always wanted in his previous project was the ability to deploy a specific version to a specific environment. And here, this is just a Jenkins dashboard. Here there is the version of the source code. And you can see that the numbers are not consecutive because sometimes the code base fails. So we remove that version from the Nexus. And you can just pick an environment, click. Wow, he was amazed. Just because of this. But you have to explain this. So finally, this is it is not actually our pipeline, it's similar. So if you're interested, this is the build part, the initial part. When we fetch the code base, we run a battery of unit tests, we build our code base, then this code base build is passed through this integration test step. When we run tests on DB, as I said before, and other tests, and then if this work, we have this other part with a QA and publish, and basically what we do is that we deploy our artifact to our AWS environment, and we run those cucumber tests, which we call user acceptance tests, because they express tests that can be written by the user. If everything is okay, we migrate the database. Oh no, actually, okay, interesting. Here there is a problem. As you can see, it seems that databases are migrated before running user acceptance tests. It is not like that. It is not like that. Actually, this task runs before this one. But I decided to preserve the way of representing things that Jenkins do. So Jenkins, if you use this continuous delivery plugin, it shows things like this, but they are not correct. So we try to use different tools and different plugins, but still we haven't solved the problem. So anyhow, database is migrated, we run user acceptance test. If everything is okay, we publish that artifact to the Nexus. If something is wrong here, or here, or here, we don't do the other steps, and we remove the candidate, and we clean up the workspace. So no more artifact, no more tag, nothing. How can we deliver the software we built? Well, actually, for example, this is the tasks, the pipeline that deploys the software to staging. So we first deploy the API, which is a separate project. We then deploy the core, which has all the business logic. Whoops. We run the migration. We deploy the front end, the web front end, which is done in Angular. And then we deploy the ESP. All together. There are still things that we are experimenting. We are always working on the pipeline. Okay? So first of all, parallelization. Our pipeline, let's say that the build pipeline, the time that we use to build the software is not the same every day, obviously, because we add tests, we remove tests maybe because they are stupid tests. And we add new features, we add new stuff, new migrations. So we are always trying to cut down the time this process takes. One way to cut down the time is to parallelize some things you can parallelize. So for example, some tests which are integration tests but can run in parallel, now they run, or we are trying to make it run in parallel. More than that, we are working on environment provisioning. So basically we are trying to, even though we don't have direct access to those machines, we are trying to build an internal machine in an automatic way so that in the future we will be able to create all the other machines in an automatic way. More, Jenkins under Git. Here I mean that we are trying to put our Jenkins stuff, our build pipeline, let's say, scenarios and configurations under source control. Because actually we don't want to lose everything. And to speed up things, we are trying to squash migration to snapshots. So our migration right now just are, let's say, there is a set of migration and they run one after the other, which means we may open a different connection and apply migration, and it takes a long. So we are trying to squash all the things we can squash in a single migration so that the process will be faster. Now, I've been thinking, when I was writing those slides, what would I do differently? If I could go back, what would I change? What I would do different in a different project that starts now, for example. So, first of all, I would create a pipeline with placeholders. You have seen all the problems we have with integration tests. The funny thing is that we knew that we needed integration tests, but we were not lazy, but we had different things to do. It was really, okay, we will do it, until it was enough, really. So, if it was for me now, I would create an empty placeholder called integration tests, and just by looking at the continuous delivery pipeline every day, one day or the other, sooner probably than we did in the other project, I would create integration tests. Secondly, extract your configuration as soon as possible. It was really a pain. It was a pain. And one of my colleagues is here, and he is the one responsible for removing all the Maven profiles, and he did it because he was tired of those profiles. He decided, okay, now I'm going to do it, and he did it, and it was fast. It was good. Finally, explaining at the beginning the values behind. We are technicians, and I know that sometimes we don't explain things to the people who is not technical, because they don't understand. No, it's not true. Just go grab a coffee and talk to them and say, oh, you know what? We need tests. We need unit tests. We need integration tests. We need a safe way to deploy our code in production. And if he asks, or she asks why, just say, because we don't know what happens right now if something goes wrong. Our process is not automated enough. Talk about money. They would understand. They will understand. Okay, we have seen the things that I would change, but there are some things I would keep the same. First of all, build the pipeline in an iterative way. Here I mean that I hope and I strongly recommend that you don't go to your job tomorrow not because it's Sunday, Saturday, but on Monday, and say, you know what, now we build a continuous deployment pipeline, a continuous delivery pipeline. No. Just build small things in an iterative way so that you can learn, you can adapt, and you can solve your problems, not my problems. So just do whatever you need. Secondly, share the pipeline responsibility. We are technicians. I know that I'm the kind of guy of, this code, I've written this code, it is so good, you don't touch it. Now it is not like that. I think that this afternoon there is another talk about collective code ownership. I suggest you to take a look. Here it is the same. The pipeline is not the pipeline of the IT guys, is not the pipeline of the dev team, the guys. The pipeline is of the team. Everybody can change the pipeline. Just a small example. How many of you here, okay, we're a few, but how many of you here don't see colors in a correct way? Okay. So, one day, one morning, I was at work, and suddenly, our Jenkins template has changed. Oh, why? Because we had a template with red and green. Red for bad things, green for good things. Now, if you don't see colors, red and green are the same. So we decided, one of the guys in my team, decided to change the template with colors more friendly for the team. So the pipeline, Jenkins, everything is property of the team. And lastly, use the tool that best fits your needs. You have heard of many texts here, JBoss, Jenkins, and whatever. Mybatis, liquid-based, Git. Please beware cargo occulting. If you are using SVN, okay, maybe if you are using SVN, just switch to Git. Anyhow, just choose the tools that best fit your needs. Beware cargo occulting. Don't do things just like this because I say it is like this. two great books. Continuous Delivery, which is sort of the Bible here. I mean, you can learn a lot. And I have to say, I think there's something like 400 pages, and I read a half while I was waiting my girlfriend in Paolo. So it is really fast to read and great book. Second book I suggest is Release It by Michael Niger, and it is one of the best books on DevOps. So I didn't have the chance to read it full, but I know that, and I read where it talks about, for example, what are the best practices, the best patterns to put your software in production in the correct way. So for example, what happens if your database goes down while your application server is still up? So take a look at those two books. And another couple of useful resources. This video, Real World Strategies for Continuous Delivery with Maven and Jenkins. I suggest this video. Actually, we didn't do at the end the things that are shown in the video, but it can teach you a lot. And from Continuous Delivery blog website, actually, which is the site of the book I suggested before, there are a good set of visualization of what is continuous delivery and what are the values behind continuous delivery. So this one, for example, or this one, or this one, or this is the last one first. That's all. Seal of approval. So, we feel time for questions? Don't be afraid.
It's slightly more a rant than a question, because I always felt that a reason for existence of a container is to have these configurations. And I still don't see any generic standard way to handle it. So I don't understand. I saw you struggle, and then finally you decided to go with the JBoss custom version. But why the hell is it that way?
So you're talking, I repeat the question. Everybody understood the question? Okay, so the question, if I'm right, is about configurations in general, right? And why we used JBoss to serve configurations. Okay. Okay. Interesting question. So first of all, JBoss was a choice of the, let's say, it was also a political choice. Because if you are in an enterprise world, you have to use enterprise tools. And JBoss is probably one of the best tools to serve, one of the best application servers in the enterprise world. So that is for JBoss. There are other solutions. So if you are using one of the buzzwords that you may hear around by people is microservices. So there are other solutions. If you don't need an application server, you can do things small. Just use different solutions like, is it Jetty, right? Or other solutions smaller. So for example, if you're doing a CRUD in Java, you can use Play, which works by itself. And you don't need to put it inside an application server, for example. So that is a solution. About configurations in general, the point is that your application depends on configuration somehow, because you are working on different environments. There are different solutions. For us, our solution was to make JBoss serve the configuration. But there are other solutions. So for example, if you read another good resource that I didn't give you, is the 12-factor app, which is provided by Heroku, and is a set of 12 rules, or let's say 12 suggestions, that makes you understand that you are doing things in the correct way with your software. And one of the suggestions there is that you should have your configuration served as an environment variable. But still, if you want to connect to a database, you need the address of the database. So configuration are there. You cannot just delete them. Other? Okay.